In this video, I'm gonna talk about a linear charge array. This is like a problem on the fourth page of the test, and it's also just like problem number 3, right? So a 13.5 microcoulomb charge is 88.2 centimeters to the right of a 23.2. So the 23.2 microcoulomb is here, and then this guy is to the right of it. Right, so it's 88.2, 13.5 microcoulombs, and this distance is 88, so 0.882 meters is this distance, right? And first question is, what's the force on the leftmost charge? The leftmost charge is, of course, going to go to the left, and this guy will be pushed to the right with equal and opposite forces. But let's look at this question here. What is the electric field 32.1 centimeters to the right of the leftmost charge? So that's right here. Okay, if that's 0.321, then this distance here is, we just have to subtract, right? So 0.882 minus 0.321, that's 0.561. Is that distance? Okay, and then we want to find the electric field. This is a positive charge, that's a positive charge. So the electric field due to this charge is going to be this way. The electric field due to this charge will be that way, right? This electric field due to this one will be bigger because that's a bigger charge and because it's closer. This one will be smaller because that's a smaller charge and it's farther away. Okay? Now I'm going to make this guy positive and this guy negative. This is just how I do it. Okay? It has nothing to do with the charge on there, it just has to do with the direction that it is, right? So my answer is going to be, the electric fields are KQ over R. Right? But I'm going to make this guy's positive and this one's, the one due to this guy, negative because it's going to be that way. Remember that electric field is away from positive charge, right? So my answer is going to be this one, 23.2. So we got to go K, which is, K is 8.99 E9 Newton meter squared per coulomb squared, right? So it's going to be K times 23.2 E minus 6, right, divided by 0.321, and don't forget to square it, right, minus the one for this one, so K 13.5 E minus 6 over 0.561 squared, right? I'm just going to type that in one fell swoop. 23.2 E minus 6 divided by 321 squared minus times 13.5 and I'm getting 1638499.04, which is 1.3456, 1.64 newtons per coulomb, right? Okay, so because I made to the right positive, that's why this one's negative. This guy's pushing it that way, right? Okay, I don't know, does that make sense? So you just set up a sign convention there. This has nothing to do with the charge. They're both positive charges, but because that guy at this point it would push a negative or a positive charge to the left, then I make that contribution negative. Let's do another example. Let's use the same charge array. And let's figure out, so let's go 23.2 microcoulombs and 13.5 microcoulombs, and make them 0.882. And now let's find, let's go over here, 41 centimeters, so 0.41 meters over here, right? What's the electric field outside of them? Because some of the questions ask that, and that is, what's on the test? Okay, so these guys are both positive, right? Both of these electric field components would be to the right. So this is actually pretty simple, right? Okay. I'm just going to guess that this one will be less because it's so much farther away, even though it's more charge, right? So both of these, the electric field here due to this one is to the right. The electric field here due to this one is also to the right. So this is just going to be KQ1 over R1 squared, right, plus KQ2 over R2 squared. They're both going to be positive because they're both to the right. So it's going to be 8.99 E9 times 23.2 E minus 6 over, okay, how far away is that guy? It's going to be this plus this, right? So it's 0.882 plus 0.41, the whole thing squared, right? Plus 8.99 E9 times this guy, 13.5 E minus 6, right, over, well, just the 0.41, that's how far we are away, right? Let's see if I can get that. And then I'm so lazy, I'm just gonna, let's go second entry. Change this one, right? Delete, 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 delete. Insert parenthesis 0.882 plus 0.41 squared, right? And then not minus, but plus. Not 0.561, but 0.41. Is that right? Is that going to be right? Why do you think so? I don't have the answer, so I want to make sure I'm doing it right. Yeah, just make sure you square your R's. And some of the R's you'll have to figure out. So that one is 8.46 times 10 to the 5th.